Now let us see what are the extra blocks which are present. We have 26 dB attenuator, a block which is going to attenuate the carrier signal to a very small value, and we are doing this to generate something called as the pilot carrier. We have discussed the concept of pilot carrier in double sideband reduced carrier, or you can say single sideband reduced carrier systems. Reduced carrier simply means that we attach a very weak amplitude carrier signal to the modulated signal, which is otherwise of suppressed carrier nature. So to add the small amplitude carrier signal to the modulated signal, we are first attenuating the original carrier signal, and once we have done that, we add it along with the outputs of the filters, the USB and LSB filters. So what we get is at 100 kilohertz, otherwise there was no carrier signal, but now we have a pilot carrier present, which will be of very low amplitude, and hence it will not affect power efficiency of the whole process, because we are generating two sidebands mainly. Power efficiency of the process will remain high. Now, I could have simply transmitted my signal after the adder stage. Obviously first passing it through the amplifiers, but if you remember, we have generated the modulated signal at low carrier frequency of 100 kilohertz. So it becomes very important first to transfer this low carrier frequency to the original carrier frequency that we want, and hence we will have to perform something called as up conversion. Whenever a modulation takes place at low frequency, it needs to be up converted so that we can achieve the final signal at the desired carrier frequency. For up conversion, as all of you must be knowing, we use mixer block. Mixer generates all the types of output frequencies, out of which we will keep F1 plus F2, this frequency combination, because we want to perform up conversion right now. So you can see that mixer takes in the output of the adder, which is from the range 96 to 104 kilohertz, with a pilot carrier present at 100 kilohertz, and the second signal is 3 megahertz crystal oscillator, again a very stable carrier frequency of 3 megahertz. So if I call output of adder as frequency F1 and output of crystal oscillator as frequency F2, then I want to choose at the output of the balanced modulator, which is this time acting as mixer. Please remember that you can use balanced modulator to operate as a mixer also. All you'll have to do is select the desired frequency range at the output side. When it is used in the generation of double sideband signal, we only choose the frequency range that corresponds to DSB signal. Now we are using it as a mixer. We will choose the desired frequency range this time, and that will be nothing but all the frequency components which will be in the form of F1 plus F2. So the 3 megahertz of frequency will get added to the entire frequency range which is there at the output of the adder. It was 96 to 104 kilohertz, present around 100 kilohertz carrier signal. The output of the mixer will be passed through a 3.1 megahertz amplifier and a filter. So this filter will make sure that we only take the signal which will have the bandwidth of twice FM, because the signal that we have generated at the output of the adder is two sidebands with the bandwidth of twice FM. In this case, FM is 4 kilohertz. So this signal has bandwidth of 8 kilohertz basically. So we have a filter at the output of mixer to make sure that we only consider 8 kilohertz signal, but because of the up conversion, we want to select the same signal which is now present around frequency F1 plus F2. So 100 kilohertz carrier signal will get added with 3 megahertz signal, and the new carrier signal, if I can call it FC1, the new carrier signal frequency will be FC1 equal to 100k plus 3 megahertz, which will be nothing but 3.1 megahertz. So what will happen to frequency 104? Frequency 104 kilo will also get added with 3 megahertz, and frequency 96k will also get added with 3 megahertz. New values will be 3.096 megahertz to 3.104 megahertz. You can see the bandwidth is still equal to 8 kilohertz, but the whole signal is now present around 3.1 megahertz carrier. So what we achieve is simply the up conversion to the new carrier frequency. Now this may not be enough. If my carrier frequency is much higher than 3.1 megahertz also, in that case we need one more stage of up conversion. So you can see that the same signal which was there around 3.1 megahertz is passed through another mixer. To have a mixer we can use a balanced modulator circuit. To this mixer we are giving a crystal oscillator synthesizer output. Now we may have a crystal oscillator generating one frequency, but using a frequency synthesizer we can generate any other desired frequency that we want. Why do we use synthesizers? So that I can choose a required carrier frequency, and so that the entire system does not become rigid for only one single carrier frequency. I can use it for different carrier frequencies and hence generate different signals.